Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. The nitration of toluene proceeds via an electrophilic aromatic substitution (EAS) mechanism. The rate-determining step in EAS is the attack of the electrophile No2+ on the aromatic ring to form the arenium ion sigma complex valent intermediate. The subsequent step is loss of a proton or deuteron from the IChO carbon to restore aromaticity. Since proton loss or deuteron loss occurs after the rate-determining step, the identity of the substituent at the position being attacked, H versus D, does not affect the overall rate of nitration. Step-by-step reasoning. 1. In EAS, the slow, rate-determining step is the formation of the sigma complex by electrophilic attack on the ring. 2. The fast step is deprotonation, loss of H+ or D+ to regenerate the aromatic system. 3. Because CH bond breaking occurs in the fast step, not the rate-determining step, there is no primary kinetic isotope effect on the overall rate of nitration. 4. Therefore, whether the ortho positions bear H or D, or a mixture, the rate of nitration is the same for all three compounds, A, B, and C. 5. Option A, ABC would imply a kinetic isotope effect governs the rate, which is incorrect since CH-CD cleavage is not rate-determining. 6. Option B, ACB is similarly incorrect for the same reason. 7. Option D, CAB makes no chemical sense. 8. Option C, A is equal to B is equal to C correctly reflects that substitution of H by D at the ortho positions does not change the rate of the rate-determining electrophilic attack step. Therefore, the correct answer is C. Therefore, the correct answer is option C.